All right, yeah, so you can see my screen. Okay, perfect. So this last time I had this demo class, and we discussed some things. I gave my introduction, and were you there for the beginning of the class? Did you hear anything, or
Yes, sir. I was in the beginning.
you were there in the beginning? Well, I just it was 11th of June, and it was named as Lecture 0. I introduced myself, and we decided that we would have this thing where we let me select this. Yeah, you can see my pointer, right? Yeah. Okay, so from Monday to Thursday, we'll mostly focus on theory, and we'll do some examples and a couple of questions as well. And Friday would be reserved for your personal specific questions regarding to the topic, and we'll solve some past papers, and we'll mainly focus on past papers on Friday and your questions, right? And then I also told you about the homeworks. They'll not be very lengthy. They'll be small, they'll be tiny, a couple of questions, and I'll share those worksheets with you after we complete a chapter. We'll do problems and theory. When we do that, I'll share some questions with you. You'll do them yourselves, and then I might share an answer sheet, a solution manual after the deadline for the homeworks. And yeah, we'll do something like that, right? So, and then again, in this lecture also, last lecture, I stressed on this, that questions are very important, right? So you should always come up with questions. If you have a question, you should openly ask, right? And you should not hesitate. There's no need to hesitate. Everyone has questions, and no question is stupid, right? Okay, so that's something that I'd like to put it out there. So you should okay, you're not appearing for October, November. So okay, so okay, for May, June 23. Right. Okay. So you're right. So that's that's useful information. So how would you? Okay. So at this point, I would also like to point this thing out, that you should tell me how would you want the pace of the course to go. What I mean by that is, one, of course, that sometimes it might be that I'm going very fast, or I might be going very slow. So you can tell me, right? So I can gauge my speed accordingly, right? And the other thing is that it's up to you. You should tell me if you want me to focus more on theory, right? And obviously, focusing on questions is is important as well. So we'll be focusing on questions. But if you want me to elaborate things or points while we're covering the chapter, you can, of course, you can always stop me and ask me to elaborate more, and so on, right? Okay. So let me just check how many people do we have. Okay, so there are two in total. Okay, so well, this was the introduction and all. So let's move on to the chapter. When I opened this file, or last time when we started doing this, were you present?
No, sir. No, I'm absent.
No, you're absent. Okay, so we'll start from the beginning, and I think I will get rid of all of this drawing over here, so we can just start from the beginning. I was doing this, and then eventually the time for the meeting ran out. So we'll do everything from the start. Right. Okay. So, well, here we have this chapter number 1. It's a very basic chapter, and it's physical quantities, units, and measurements. So it's just about it's basically just giving you an intro to physics, which is that when you're doing physics, you need some variables, right? Or you can say quantities to describe your laws of physics in them, right? So for example, when you push something, something is happening, right? And what is that? That is basically a force. You applied force and the thing moved some distance. So what you did over here is you assigned physical quantities, or you assigned variables to the action that you just performed. So again, I think I should use this. I should make use of this, right? So suppose you push a block, right? And this block is going to move some distance, right? When you apply some force on it. So right now, let's suppose that you don't know what is force and you don't know distance and all of that, right? Let's start from the beginning. So there you see a block, you push it, it moves, the block will move. Now you need something to describe what just happened. So that's where these physical quantities come in. So you use the concept of something that's called force. So when you pushed something, you call that I applied some force F, and then it moved. So you have to assign a variable for this behavior. So you say that it moved some distance, d. Let's call it d, right? So this is the length that it moved, and this is the force that you apply. So that's what physical quantities are, right? So it's something that you can measure, but it's also something that you use to describe the laws of nature, right? Okay, so that's your physical quantities, and here we have some of the physical quantities. uh, they can be divided into a group of two, basically. So one is where we have this thing which is called basic or base quantities, right? And these are those quantities which do not depend on any other quantity, so they are themselves alone. So for example, we have this thing that is called length, and that's it's measured in meters. So you assign a unit to this quantity, and uh, that unit is meters, right? And the SI unit for that is just M, right? So this is all pretty basic stuff. Then you have mass. Mass is, you can, well, a very basic definition is it is the amount of stuff. But then, of course, you can go into philosophies of these things. What is stuff then, right? And so on. But we'll not do that at this point. So mass is defined as just something that the amount of stuff, and it is measured in kilograms. Now note over here that this is kilograms. Now kilo is something separate and grams is something separate, but in this thing meters, it's just meters. But by separate, kilo is not a unit. The kilogram entirely, it's one unit. So I cannot say that this is derived. But the point that I'm trying to say over here, that kilo is different and gram is different, we'll move further into the lecture and you'll understand what I mean. But the kilogram itself is one unit, one specific unit, and the mass is measured in that. Similarly, we have time, which is measured in seconds. We have thermodynamic temperatures and amount of substance, Kelvin and moles, right? So we'll get into these at a later stage. We'll be working mostly with length, mass, and time, and we'll see that you can make a lot of physical quantities from these basic quantities. So that's where the derived quantities come in. What is a derived quantity? So for example, consider, again, let's just consider force. Now I'm sure that you at this point will not dig into the philosophy of, or the concept of what is this expression that I'm writing, but I'm pretty sure that you already know about it. We know that F is equal to ma, right? Is there anyone here that is not familiar with this expression? Right. So I'll assume that you're familiar, right? So what is this? Just means that well, we'll not get into what it means, but it's just force which is equal to mass times acceleration. I'm not getting it into its meaning as of this moment, because we will move on and we have an entire chapter dedicated to defining force and accelerations and all of that things, right? Right now we're just discussing physical quantities and units. So we know that mass, the unit for mass is what? We know it's over here, so it's just kilograms, right? And we know that this kilograms, it's a basic quantity, right? It's a basic quantity. What is acceleration? Acceleration is defined as the change in velocity divided by time, right? So if you have to write it in very simple terms, you can just write it as a ratio of velocity to time. So, well, again, I'll not get into what it means right now, but well, I'm pretty sure that you already know. So if your velocity changes, that means that you're accelerating. When you're accelerating, accelerating just means that you're changing your velocity or you're changing your speed. So whenever you do that, you call that acceleration, that I'm accelerating. Right. So the units for acceleration would then be the units for velocity. But what is velocity? Velocity is defined as the change in distance per unit time, right? So you can just use x over t. So this is your velocity. So this means that in place of v, I can write x over t, which means that this would be x over t and then divided by t. Or let's just use L, because at this, it's just distance, right? So you can just use any variable. So let's just call it L. So what is L is the length, and the units for that is meters, and it's a basic quantity. So what I have done over here is I've converted all my quantities here in basic quantities, just so I can write down a unit for force in terms of all of these base quantities. And if I can do that, then then this F is basically my the units for F are the derived units, because they would be a combination of all of these basic units, right? And let's just see what I mean, right? So this is acceleration. Now let's put all of this and this together. So what do we get? We get so the units of mass is kilograms multiplied by, we have to multiply it with the units of these things. So we know what are the units of length, they're meters. We know what are the units for t, so I'll just put a divisor, and we have sorry, we put seconds, right? So the basic units for time is seconds. Then we divide this thing again by the seconds, the units of time. So this just comes to kilograms meters per second squared. And so these are the derived units for force. And we define a name for this units. We just call that whenever you see this thing, kilograms meters per second squared, you also call it newtons, right? Okay, so is there any question so far? You can unmute, and if there is no question, you can say that no, there is no question. So let's try to eliminate this communication gap, right? Okay, perfect. No sir. Okay, so this was just me telling you very basic things about units. Now let's use all of this knowledge, right? And let's try to solve this problem over here. I don't know. My screen just got stuck. Anyways, yeah, it's fine. It's fine now. Okay, so you can see this example one over here, right? So it says, what are the derived units for density? Now we know what is density. Density is defined as, we use rho. It is defined as mass per unit volume. So the amount of stuff per unit volume that this stuff is going to occupy. Yes, of course, of course, of course. Yes, you can, right? Okay, so right, so this is what we have as a density. Density is defined like this. Now they're asking you derived units of density. So we use this brackets. So if I write this as this just means that I'm saying units or dimensions of rho. But and rho is simply density, right? So this rho is density. Okay, perfect. So that means then I can write this whole expression as the units of rho is equal to the units of mass over the units of volume. So, well, we know that the units of mass, the SI unit for mass is kilograms. What about volume? Well, what is volume? If you really think about it, volume is just something, it's a three-dimensional thing, right? So what I mean by that is you have, let's suppose you have this axis, right? So this is X, Y, and Z. Okay, perfect. So you have these this axis system of coordinates, and if I were to combine all of these, what would I get? I would get volume, right? So what I mean by combining all of this is just taking the product of X times Y times Z. And once I take that product, visually that looks like a cube for this coordinate system, right? So taking the product of X, Y, and Z visually looks like a cube. So it would look something like this, right? So here we are combining these axes, right? So it looks, you have to forgive my drawing, but this is a cube. So take my word for it, right? So this is a cube. And when you take X times, I think I should use X as this because then it confuses with the product symbol. So X times Y times Z. So we know what are the units for X. It's a length. It's just a length. So it would have units meters. Then I have Y. What units would it have? It would again have units meters. Then I have Z. It would have units of meters. And then these are being multiplied. So I just put a multiplication symbol. So once I do this, then I'm multiplying meters times meters times meters. And what would this give me? Meters cube, right? So this is the power of the base. So we have the base is meters, and you just add the powers because we have the bases are being multiplied, and you would get meters cube. So hence the volume is just meters cube. These are the units for volume. And what this means is that then this means that the derived units for density are simply kilograms per meter cube, right? So up to this point, do you have any question in your mind? Anything that you did not understand, or you want me to repeat it, or even if you think I'm going too fast, you can let me know, or if I'm going too slow. Okay, okay, perfect. So let's continue, right? Now the next topic is again it's a very it's a simple topic. It's this prefixes, right? And we have different prefix, and these are those things that you see, for example, when you write meters. Now meters is just, it's a very basic unit. Sir, understood, but about volume, you did not understand the volume part, the units for volume.
Yes, sir.
Oh, right,
Volume.
okay. Right. So I maybe this was a bit confusing. I'll give you a very simple example. If you were to calculate a volume of a cube, or even if this is a rectangle and you were to compute the volume of a rectangle, you just what you do is you take your length, you multiply it with width, and you multiply it with the total height. Are you familiar with this expression for volume?
Yes, sir.
If you're
Yes.
not, you can, okay, you're familiar. Even if I'm saying something and you don't know, there is, you can just say that no, you don't know it, right? So I'll elaborate more, right? Okay, so if you're familiar with this thing, then we know that the units for length are what? And your very basic units that you would use for length, we saw over here that those are meters, right? So I'll put meters for length. Again, you know, if you're going to measure width of something, width of this cube, you'll use the same meter rule or something, and you measure it in meters. So maybe it's 1 meter, 2 meter. So something is 1 meter in length, it is 0.5 meters in width, and then it's high, let's say, suppose it's 1 meters high. So everything is being measured in meters, right? So what I'm just doing is then I'm just writing these units, and then I'm using this product symbol. So this is being multiplied, and then this is being multiplied like this, right? So these units are then being multiplied. So when I have 2 meters, that would give me meters times meters is meters squared. Then I have another meter, right? So this would, when this combines with this, it would give me meter cube. So is that okay? Do you, or your question, or is your question that you don't understand these powers, or is it okay? Are the units for volume okay, or are you still confused? Do you still have any problem?
Sir, okay.
Okay, okay. So okay, perfect. So, but if you have any problem, you can let me know, right? If you still did not understand something, you can ask me again and again and again. So that's not a problem. But what I'm teaching you, that should be clear, right? So if you don't understand it, you should ask me. If I explain and you don't understand it again, then you should ask me again. So I don't have a problem with that. I enjoy I enjoy questions, basically, right? So okay, so if you understood this, then we can move on to this topic of prefixes. Right. So here we have, so I was telling you this thing, that normally we write meters. If you want to measure something, you use meters. Sometimes you also use centimeters, right? Is that true, right? That's true. You know, you're aware of the units, centimeters, meters, and so on, right?
So it's for measurement, no?
Yeah, exactly. So what I'm trying to tell you now is, what does this centi basically means? Now in this thing, this centi is a prefix. That's the reason when running out of time, this meeting, but God, this is a problem. So we'll get this thing fixed by tomorrow, inshallah. And so this will not be a problem, this running out of time thing. It says I have 10 minutes left. Anyways, let's make good use of those 10 minutes. So yeah, so this centi is a prefix. Similarly, when I was over here, I told you that kilo is different and grams is different. So that's what I meant. Now, kilo is just a prefix. So for example, let's come back over here. Okay, let me give you an example by this kilograms. Suppose you say that something weighs, let's use a different number. Let's say 2 kilograms, right? Let's say something, the mass of something is just 2 kilograms, right? So if this would mean that it has a mass of 2000 grams. Now, how or why? Well, this K represents, this K is just one or you can say it's just 1000. Similarly, okay, so that's how, if you look at this table over here, you can see what I'm talking about. So that you see this kilo is just 1000. So what we do is to make our numbers, to write them as in a compact form. अपने numbers को basically अगर आपने छोटा करके लिखना है, right? So आप ये prefixes use करते हो, right? Okay, so what I'm saying is, let me write something down and let me ask you if you understand what this is, right? So suppose I'm writing 7.
मेरे मेमोराइज करने पड़ेंगे मल्टीपल्स.
You mean याद करने पड़ेंगे?
Yes sir.
Oh yes, it's always a good idea to memorize these. And I know Abhi, when you look at these, they appear as though it's something very hard, or like there's so many numbers. But you'll start when we'll solve problems, we'll use them so much that you'll get familiar with all of these prefixes. So if I write this thing 7x, what does this mean in terms of the algebra? What is happening over here? 7 is being multiplied with x. Would you agree?
Yes sir, multiplication.
Yeah, so 7 is being multiplied with x. So that's exactly what happened over here in 2 kilograms. What happened was 2 kg. Now, grams is a particular unit, right? K just 2 is being multiplied with k. And what is k? K is 1000. So what I can do is I can write this as 2 times 1000. So what I just did, I just used the value of k, which was 1000. And then I have this g, which is grams. So I'll just put that g. So this is how I got 2000 grams. So what I have noticed is, even for me, when I was doing, I always had this problem in this converting from one unit to another unit. So, but I think this thing makes it easier, that if you understand the concept of 7x, meaning it's 7 multiplied by x, then you should not have a problem in understanding what I just did with 2 kilograms. Converting kilograms to grams is just that I should write the value of k, which is 1000, and then multiply it with 2, right? Because this is just 2k, which means 2 is being multiplied with k. And then you are left with the unit grams, which is g. And so that means you can convert easily from kilograms to grams. So the conversion is very simple. Let me give you let's do another example. So let's use these smaller units. Now let me get rid of the 7x, or I'll just write it over here, so for future reference. So we have centi, and centi is 0.01. So now if I have 1 centimeters, and you're asked to go from centimeters to meters, it's very easy, because we understand the concept of 7x. It just means 7 multiplied by x. Similarly, 1 centimeter, c is 0.01, right? This is c from here. So that means that if I sorry, you were saying something?
Smaller quantity to larger quantity, na?
Yeah. So yeah, exactly. So what we're so the way to do it is, then you just replace the number which is for c, which is 0.01, and then 1 is being multiplied with c, right? So it is 1 multiplied by 0.01, and then c to humne likh diya hai 0.01. What is left? Meters. So you just write meters. So this is equal to 0.01 meters. So that's why you say that 1 centimeter is equal to 1 over 100 meters, or you can say 0.01 meters, right? So this is just, I have when you divide 1 by 100, you get 0.01. So this is so at least I believe that in this way conversion seems very easy. Well, if you understand this concept of 7x, and that's all we are doing by just putting prefixes. So we don't want to write this 1000. For example, if 2 kilograms, hum baat pe wapas aa jaye. So we don't want to write this 1000 again and again and again. So we just to make our life easy, we just put this prefix K and we say that K is 1000. So we just write 2 kg for 2 kilograms. So kilo is just a prefix. So I hope that this makes this thing a bit more understandable, prefixes. If you have any question at this point, you can ask me right now. Any question? Okay, I think not, right? You're still here. Yes, no problem, Will. Okay, perfect. So now we have this thing that, okay, so these are the symbols for these prefixes. So like I give you an example, kilo is just K and its value is 1000. Now you can write this 1000 even in a shorter notation, which is 10 raised to power 3. So what this means is that what I'm doing is I'm doing 10 multiplied by 10 multiplied by 10. And this gives me 1. And then how many zeros? I have 1 0, 2 0, 3 0. So this is just 1, 2, 3, 3 zeros. So you get back to the number 1000. So the idea of prefixes is just to make our lives easy, right? So it's just making our lives easy by reducing the length of numbers that we have to write down each time. Okay, right? And now then there is this thing that is called the order of magnitude. When we are performing experiments, so for example, you have this thing, you have a speed of light. Let's write a very average value for that. 3 into 10 raised to power, is it 8 kilometers per hour? If I'm not wrong. So what we do over here is when you're performing an experiment and experimentally you want to measure the speed of light. So what you do is we don't really care about this number. What we really care about is because this number can have errors. So maybe what I'm saying is gonna go through over your head. But if you remember this, it will help you moving forward. But so this 3, it's just a number, and because there can be so many errors in your experiment, random errors, systematic errors, which we will talk about in detail moving forward. But the number we care about is this one, which is basically into 10 raised to the power of something, which is 8 in this case. So if experimentally I get something which is being multiplied with 10 raised to power 8, then we say that our experimental value for the speed of light is okay, because it is agreeing with this original